Hello, in this video I'll be covering degrees of freedom and critical value. Now we can find critical values for chi-square goodness of fit test by using the formula chi-square dot INV dot RT, with the two parameters being probability or alpha and degrees of freedom. The number of degrees of freedom used in chi-square dot INV dot RT function depends on the type of distribution you're fitting. In general, degrees of freedom is the number of bins minus 1 minus the number of parameters of the distribution that are estimated from the data. For normal distribution, we need to estimate two parameters, mean and standard deviation. Therefore, the degrees of freedom is the number of bins minus 3. Similarly, for exponential distribution, since we only estimate lambda, the degrees of freedom are number of bins minus 2. Now let's complete our goodness of fit test back in Excel. Now we need to find number of bins, the degrees of freedom, we need to calculate our chi-square statistic, and our critical value. So now number of bins would be count, and then this column right here, which is 41. Now since we are assuming this is a normal distribution, we would do 41 minus 1 minus the two parameters. So now let's calculate the chi-square statistic. This is the sum of all of the values we calculated under the chi-square formula. Now let's calculate the critical value. Now the critical value would be chi-square dot INV dot RT, with the probability here being 0.05, since that is a commonly used probability in goodness of fit tests, and the degrees of freedom being 38. Now here we can see that 53.38 is smaller than 253.401, which means our critical value is smaller than our chi-square statistic. So in order for our assumption to be true, the critical value has to be greater than our chi-square statistic. So our assumption that the data follows normal distribution is wrong. And that concludes goodness of fit test.